And let's start! Intro to Web3.js. By completing lesson 5, our zombie dApp is now complete. Now you're going to create a basic web page where your users can interact with it. To do this, we're going to use a JavaScript library from the Ethereum Foundation called Web3.js. This can be interesting. So, what is Web3.js? Remember, the Ethereum network is made up of nodes, with each containing a copy of the blockchain. So every node has a copy of the blockchain. When you want to call a function on a smart contract, you need to query one of those nodes and tell it, I'm reading here, the address of the smart contract, the function you want to call, and the variables you want to pass to that function. Ethereum nodes only speak a language called JSON-RPC, which isn't very human readable. A query to tell the node you want to call a function a contract looks something like that, maybe a bit bigger. So this is okay. Luckily, Web3.js hides these nasty queries below the surface, so you only need to interact with a convenient and easily readable JavaScript interface. Yes. Instead of needing to construct the above query, calling a function in your code will look something like this. So we have cryptozombies.methods.createRandomZombie with a leak Nakamoto. Okay, and we send from an address with gas. This looks better than this, for sure. So it's like an interface. Okay, so maybe a little bit. Okay, I think this is better. So getting started. One moment. Okay. So. Okay, so can we start? Can you hear me? I hope so. Can you hear the music in the background? So, getting started. Depending on your project workflow, you can add Web3.js to your project using most package tools, or package manager, we should say. npm yarn bower. If you use bower, go out of this live stream. Or you can simply download the minified.js file from GitHub and include it in your project. Okay, script language, okay, so this is also a minified version of Web3.js. Okay, since we don't want to make too many assumptions about your development environment and what package manager you use, so here they say package manager, for this tutorial we're going to simply include Web3.js, I think they mean, in our project using a script tag as above. Okay, so put it to the test. We've created a shell of an HTML project for you, index.html. Let's assume you will have a copy of web3.min.js in the same folder. Go ahead and copy-paste the script tag above into our project so we can use web3.js. So it's literally this. Okay. Okay, let's copy-paste this. Include like this. No. I have to remove the comment. Okay. Done. Next chapter. Web3 providers. Great. Now that we have Web3.js in our project, let's get it initialized and talking to the blockchain. The first thing we need is a Web3 provider. Remember, Ethereum is made up of nodes that all share a copy of the same data. Setting up a Web3 provider in Web3.js tells our code which node we should be talking to handle our reads and writes. It's kind of like setting a URL of the remote web server for your API calls in a traditional web application. I hope that you can read. You could host your own Ethereum node as a provider. However, there is a third-party service that makes your life easier, so you don't need to maintain your own Ethereum node in order to provide a dApp for your users. Infura and Alchemy people will be very upset. Infura, because there are some alternatives like Alchemy or QuickNode. Infura is a service that maintains, I think also Moralis. Infura is a service that maintains a set of Ethereum nodes with a caching layer for fast reads, which you can access for free through their API. Using Infura as a provider, you can reliably send and receive messages to from the Ethereum blockchain without needing to set up and maintain your own node. This is nice. You can set up Web3 to use Infura as your Web3 provider as follows. Okay, why var, by the way? However, since our dApp is going to be used by many users, and these users are going to write the blockchain and not just read from it, we'll need a way for these users to sign transactions with the private key. Okay, note Ethereum and blockchain use a public-private key pair, okay. Cryptography is complicated, so unless you're a security expert and you really know what you're doing, it's probably not a good idea to try to manage users' private keys yourself in your app front end. But luckily you don't need to, there are already services that handle this for you. The most popular of this is MetaMask. MetaMask is a browser extension for Chrome and Firefox and lets users, I think also for Brave and Edge. It lets users securely manage their Ethereum account and private keys and use these accounts to interact with websites that are using Web3.js. If you haven't used it before, you'll definitely want to go and install it. Then your browser is Web3 enabled and you can now interact with any website, okay. And as a developer, if you want users to interact with your dApp through a website in their web browsers, you'll definitely want to make MetaMask compatible. Okay. MetaMask injects their Web3 provider into the browser in the global JavaScript object Web3. So there is an object called Web3. So your app can check to see if Web3 exists and if it uses Web3 current provider as its provider. Nice. Here's some template code provided by MetaMask. Okay, so this is the template. You can use this boilerplate code in all the apps you create. Nice. You create an empty script tag before the closing body. Okay. Copy paste the template. Okay. So it's literally just this. Yeah, you're welcome. This looks simple. Maybe it's not. Let's see. Okay, so this was simple. Just copy pasted some stuff. Next chapter. Let's go fast. Chapter 3, talking to contracts. Now that we have initialized the Web3.js with a MetaMask Web3 provider, let's set it up to talk to our smart contract. Okay, Web3.js will need two things to talk to your contract. Address and ABI. Okay. So, contract address. After you finish writing your smart contract, you will compile it and deploy it to the Ethereum. We're going to cover deployment in the next lesson, but since that's quite a different process, we have decided to go out of order and cover Web3.js first. Okay. Can you read? I hope yes. Okay, after you deploy your contract, it gets a fixed address on Ethereum where it will live forever. If you recall from lesson 2, okay, maybe I can. The address of the CryptoKitties contract on Ethereum mainnet is, okay, so I remember, but not very well. You will need to copy this address after deploying in order to talk to your smart contract. Contract ABI. The other thing Web3.js will need to talk to your contract is its ABI. ABI stands for Application Binary Interface. Basically, it's a representation of your contract methods in JSON format that tells Web3.js how to format function calls in a way your contract will understand. Okay, since I'm covered, okay. Let's go to the test. Once you have your contract address and API, you can instantiate it in Web3 as follows. Okay, so something like that. So put it to the test. 1. In the head of the document, include another script tag for Cryptozombies _ API.js. Okay. Cryptozombies API. Okay. So I think that I should. Okay. Script tags. Okay, so let's see. Let's remove this. Okay. So there is this one, Cryptozombies _ API.js. The type is It should be this one. Okay, so this is the first one. Now, okay, at the beginning of our script tag in the body, okay, declare a var named the Cryptozombies, but don't set it equal to anything. Later we will use this variable to store instantiated. Okay, var name Cryptozombies. Var. So just here, var Cryptozombies. Okay. And now, next create a function named startup. Where is the tree? Okay. Create a function named startup. The first thing startup should do is declare a variable. Okay. Okay, so this is okay. Okay, so let's see here. Okay. Let's see. So something like that. Function called startup. Create a function. Okay. So something like that. The first thing so is declare a var named var Cryptozombies address equal to your contract address, something like that. Okay, this is the address of the Cryptozombies contract on mainnet. Cryptozombies. Okay, let's try like this. Okay, let's instantiate our contract. Set Cryptozombies. So this Cryptozombies. So I think it's this. So it's like okay. So I think something like that. Equal to this. I think it's this one, Cryptozombies, and then Cryptozombies address. I don't know if it's correct or not. Let's try. It worked. Nice. Okay, perfect. Next chapter. Next chapter. Maybe it's a bit. Maybe I should put this. Let's put this somewhere else. Okay. Second. Okay. Now, calling contract functions. Our contract is all set up. Now we can use web3.js to talk to it. User with web3.js has two methods we'll use to call functions on our contract. Call and send. Okay, call is used for view and pure functions. It only runs on the local node and won't create a transactions. Okay. Okay, using web3.js, you will call a function named myMethod with the parameter 1, 2, 3 as follows. Okay. Okay. Send will create a transaction and change data on the blockchain. You will need to use send for any functions that aren't view or pure. Okay. Getting zombie data. Let's look at real example. Okay, okay, this is very long, but okay. Okay, we have gone ahead and copied the get zombie details into the code for you. Okay, let's create a similar function for zombie to owner. I can't remember anything other than that. Get zombies details ID. Define zombies to owner. Zombies to owner. Similar functions for zombie to owner. Okay. Function. If you recall from... Okay, define a JavaScript function called zombie to owner. Okay. This is the function. Similar to the get zombie details above, it will take an ID as a parameter and it will return a web3.js call to zombie to owner on our contract. Okay. Call to zombie to owner. I think it's something like that. Okay. Now, below that, create a third function for get zombies to owner. The function definition looked like this. So get zombie by owner. So let me copy this. Okay, so I'm defining, okay. Function get zombies to owner. And maybe we need this. Address owner. Let's see. Our function will take owner as a parameter and return, okay, return Cryptozombies methods zombies by owner. Okay, let me put this. Our function will take owner as a parameter. Okay. I think it's just this one. Like this and this. Okay, let's see. Done. So I've created 3 functions. It worked. Nice. Next chapter. Okay, chapter 5. MetaMask and accounts. Awesome, you've successfully written front-end code to interact with your first smart contract. Now let's put some pieces together. Let's try we want our app's homepage to display a user's entire zombie army. Obviously, we first need to use our function getZombiesByOwner to look up all the IDs of a zombies the current user owns. But our Solidity contract is expecting owner to be a Solidity address. How can we know the address of the users using our app? Interesting. Now, getting the user's account in MetaMask. When MetaMask allows the users to manage multiple accounts in their extension. This is nice. You can see account is currently active on the injected Web3 variable via var web user account equal web3.at.accounts 0. That's the first one. Because the users can switch the active users. Okay, so the account with the index 0 is the one in use. Okay, nice. Set interval loops. Okay. Put it to test. Let's make it our app will display the user zombie army when the page first loads and monitor the active account in MetaMask to refresh the display if it changes. Declare a var named user account but don't assign it to anything. So, var. Can we see? Okay. 2. Create set interval code here. I think I'll copy paste here. Boilerplate. This is what I like. Okay, here. It's very bad formatted. Oh. Okay. Okay. Nice. Okay, replay 3. What is the 3? Replace the update interface with a call to get zombies by owner. Replace the update interface with a get zombies by owner and pass it user account. Where is it? Oh, okay, and pass it user account. Makes sense. Chain a then statement after zombies by owner. After get zombies by owner. And pass the result to a function named display zombies. Okay, so something like that. Okay, let's check the answer. Done. Amazing. No. Next chapter. Chapter 6. Displaying our zombie army. This tutorial wouldn't be complete if we don't show you how to actually display the data you get back from the contract. Okay, display zombie data, rough example. Okay, so this is a rough example. Let's try to just do this part, and then we'll understand what we need. Put it to test. We created an empty display zombies function for you. Let's fill in display zombies. Where is the display zombies? Where is the display? Okay, here. The first thing we will want to do is empty the zombies div. In jQuery, you can do this. jQuery stuff. I can't believe this. Next, we'll want to loop through all the IDs using a loop. Okay, so this is a loop. AB1 mind, thank you for following. This is a loop. Inside the for loop, copy paste the code block above that called get zombies IDs, and then okay, so this it should be this. Okay, let's see. Okay, this should work. Done. Easy. Very nice. Next chapter. Chapter 7. Sending transactions. Awesome! Now our UI will detect the user's MetaMask account and it automatically display their zombie army on the home page. Now let's look at using send functions to change data on our smart contracts. There are a few major differences from call functions. Sending a transaction requires a from address. Okay. Sending a transaction costs gas. Okay. Creating zombies. Function created zombie. Okay. An example. Or function send received error. Let's do this. Put it to test. We've added a div with ID tx status. Where is tx status? Okay. This way we can use this div to update the user with messages with the status of our transactions. Okay. Below displayed zombies, copy paste the code from create random zombie above. Okay. So display, but where? Below displayed zombies. Do you mean the function? Start here. Yes. Copy paste the code from create random zombie. Okay. This looks very messy. There we go. No. Okay. So I copy pasted this one. Let's implement another function, feed on Kitty. Okay. But where? Okay, so let's create another function. So this is the function. Function feed on kitty takes two arguments, zombie ID and kitty ID. Okay. No. Okay, and kitty ID. Okay, the TX status text should update to eating a kitty. I know. Okay, the TX status text should update to make it call feed and pick our content and pass the same two arguments. Okay. Create zombies. Okay, I think it's something like this. It's not explained very well, but TX status should be eating a kitty. This may take a while. Okay. It's a crypto kitty, it's not a kitty. Make it call. Make it call. Make it call feed on kitty on our contract. Contract should be the account. It's not super clear, but let's see. Let's call feed on kitty. Can you read them? Okay. Maybe there is then. Account, then text return, send. Okay. The mess. Okay. Text. I'm not done yet. Okay, so the success message on text status should read ate a kitty and spawned a new zombie. Okay. I think I don't need this. Get zombie by owner. I don't know if I need this line or not. Maybe not. Let's try this. No. Let's try to comment it. Okay, we have an error. Maybe I should put this here. Maybe I can make this a little bit smaller. Okay. So let's see what's the error here. Return Cryptozombies that methods fits on Kitty. Okay. Return Cryptozombies methods fit on Kitty. Okay, so I didn't like this. Function feed on Kitty. Okay, why we don't like it? Okay. The logic for calling feed on copy paste the code from create random zombie above. Let's implement below this one from the okay. Let's start here. Maybe okay. Paste the code for create random zombie. Okay. The logic for calling a transaction and a successful transaction result in a new zombie being created for us. Okay. Okay. Maybe this not. Okay. I've commented the last line, but it was not because I want to refresh the UI after I've eaten the kitty. Next chapter. Chapter 8. Calling payable functions. The logic for attack, change name, and change DNA will be extremely similar, so they are trivial to implement, and we won't spend time coding them in this lesson. In fact, there's already a lot of repetitive logic in each of these function calls, so it would probably make sense to refactor and put the common code. Okay, level up, okay, some stuff. Let's put it on test. Let's add the level up function below feed on Kitty. Okay, where is the start here? Okay. So function. The function level up. Okay. One parameter, zombie ID. Pre-transactions, it should display the text status text leveling up your zombie. So, okay, I'm getting the idea here. Leveling up your zombie. Okay. When it calls level up in the contract, it should send. Okay, so now it should call the level up on the contract. So, okay, I think that I got the idea of this stuff. Cryptozombies methods feed on Kitty zombie ID. Let's remove it. Send from user account and receipt. Okay, it should send. Okay. Okay, it's this one. So this is the send and Cryptozombies. Okay. So, okay, so it calls level up on the corner should send converted to way. Okay. We don't need to redraw the UI by querying a smart contract with get zombie by owner. Because in this case we know. Okay, so we don't. Okay. Let's try to do this. There is a small error, but I think it's just function level up. Maybe not this one. No. Let's see. Function level up zombie ID. This error handling is really horrible. Below Fidon Kitty. Okay, level up. What's the problem? Okay, I don't know what's the problem here. Maybe we can remove this. No. It says that this function is an error. Why? Level up function below Fidon Kitty. Okay. Below Fidon Kitty, zombie ID. Leveling up your zombie. Okay. Transaction should display text status. Okay. When it calls level up on the contract, it should send. Okay. Maybe user can level up. Okay, zombie ID external payable. Okay. I don't know what's the problem here. Function level up. Function get zombies IDs. An error text status. Oh, there is always an error. Function level up zombie ID. Okay, let's go here. Let's add the level up function below Fidon Kitty. The code will be very similar to Fidon Kitty. Okay. Return Cryptozombies methods level up zombie ID dot send from user account value on recipe on error. Okay. Okay, I think I just missed a part here. On recipe, I think it should be. So we need just a different text here. And we don't need this. No. Let's see what's the problem. Okay. But I think it's just... return send on. Okay. Okay, let's try now. Done. Okay. Let's go. Chapter 9. Subscribing to events. As you can see, interacting with your contract via web3.js is pretty straightforward. Once you have an environment set up, calling functions and sending transactions is not that long different from a normal web API, okay? Listening for new zombies, use an index. Okay, let's just read here. Let's add some code to listen for the transfer event and update our app's UI if the current user receives a new zombie. Okay. We need to add this code at the end of the startup function. So let's go here, startup functions here. Okay. To make sure the Cryptozombies contract has been initialized before adding an event listener. At the end of the startup, copy paste the code block above, listening for Cryptozombies event transfer. Okay, let me read which is the for the line to update the UI use. For the line to update the UI. Okay. Listening for new zombies. So you need to add this code at the end of the startup to make sure you add at the end copy paste the code block above listening for Cryptozombies event transfer. Cryptozombies event transfer. I think it's this one. Okay. Okay. For the line to update the UI, okay, here. Use get zombie by owner user account, then display zombies. Okay, so this is the line to update the UI. That's it. Done. Amazing. Next chapter. Done. Super easy. Congratulations, you received and written your first Web3.js frontend. Phantom of Web3 zombie. Where is? No name. Ah, this one. Wait. No. Okay, let me put this here. Let me move. Never do this in your live streams. This one. Okay, nice. Looks rare. Nice. A lot of stuff here. Save. Okay, done. Next. That was easy. 1 hour. Amazing. Perfect. Lesson 7 will be out in the next few weeks. Okay. I want to trust you. I'll do this as soon as this will come out. Amazing. We are done. Perfect. Let me also take a screenshot. Maybe how can I do the wait a second. Perfect. Let's brag on Twitter. Lesson 6 done in less than 1 hour. I missed the coding. Bum bum dum 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 dum. Nice. Amazing. Let's do this on Twitter and then I think it's done. Perfect. Perfect. Very happy with the result. The colors seems a bit broken here, but okay. So we're done for today. I just wanted to make the episode 6 of Cryptozombies again, so we'll post this on my YouTube channel. And yes, that's it for today. I want to also do some more Solidity development stuff, live coding for real. I don't know if there are other courses that I can do, but I like Cryptozombies a lot, to be honest. So we're done for today. Thank you so much. Bye bye.